दरवाजा बंद कर देना। So welcome to all the attendees who are joining the webinar. We are webcasting this webinar live also. So I'm just sharing with you the link for this webcast. This link can be shared with anyone who is interested to watch. Although this webinar can handle 3,000 people, so there is no shortage of people who can attend this session. But still, if somebody wants to watch only on the YouTube, the link has been shared in the chat window. We will start at 6:30 after about 13 minutes. Okay, so please stand by and I'll join at 6:30 India time. Thank you. Once again, I would like to clarify that the chat window is not to be used by the students as far as possible, by the participants. The chat window is mainly meant for us to share administrative messages. Anything that you want to discuss, please come only on the Q&A window. Try to avoid the chat window unless there is an emergency. So hello and welcome to all. We will start in about 3 minutes from now. That is the standard scheduled time for today's presentation. So welcome all of you for the third and the last day of this 3-day online workshop, DIRCA 2022. Please stand by for a couple of minutes. Okay, friends, so it's 6:30 in India, and we will start the proceedings. I would like to once again welcome all of you. And straight away, I'm going to start the recording. We can start today with Sohan. So Sohan, over to you.
Yes, sir.
Yeah, you can share your screen and start.
I hope my screen is visible and my audio is clear.
Yes.
All right. So up until now, we have been looking at on for day one, we looked at the principles of aerostatics and the concepts behind how an airship is designed. So in today's session, in yesterday's session, we looked at we took a case, we took some design requirements, and then we designed a airship for that. So today we are going to talk about how do we actually realize that design. So once you have those design numbers and you have all the your size of the envelope, you have all the other components designed, how do you actually go into fabrication? So the first thing and the biggest thing, as you all know, in an airship is an envelope. So I'm going to be talking about how do you fabricate an envelope. So that's the first topic for today. So as I mentioned, we already have the design output. So the output diameter has come out to be around 0.65 meters. That's the maximum dia. And we have picked a modified GNER shape. These were the design requirements, and the components mass were also estimated yesterday. So this is the CAD model of the design that we have in mind. So we basically have the envelope, we have 4 fins, which are put in the plus configuration, and the bottom one would have a yaw motor there. And gondola, as you can see, compared to the entire airship, it's a bit small, but it's appropriately powered. So let's go forward. So then after we designed the envelope, the next thing we wanted to do was generate the petals. So a template for petal would look something like this. So this was done using the help of that spreadsheet that we made yesterday. So once you have this, the coordinates for the petal, you would want to plot them on a 1:1 scale, get a printout, either on a flex sheet like you have big banners, or on or on paper. But it has to be 1:1 scale. So for example, this petal is nearly equal to 3 meters. So it has to be also equal to 3 meters. Actual size of the petal needs to be translated into into the printout form. So what you would do then is you would cut out this, and you would then cut these petals on the envelope material. So let's go ahead with the fabrication process. So let me remind you, the material that we picked was metallized polyethylene, MPET. So it looks something like this. It's a shiny material. So some of the properties is that one layer is metallized and the other layer is polyethylene. And note that it's only sealable on one side. That's because one layer is metallized and the other layer is polyethylene. It's the polyethylene layer that is sealable. So if you have 2 sides, only one, you can seal only on one side. And also note that the thickness of this material is only 30 microns, which means it's a very, very thin and light material, and also means that it's difficult to handle in the sense that if you crumple it, it's going to have cracks and holes in them. So you have to be very careful while handling such a thin material. So what's the first step of making the envelope? So first we have to actually set up a table. So here you see what we did is we basically put together 2 big tables. So we have an area of about 4.5 meters long and about 80 centimeters wide. I think 70 to 80 centimeters wide. So we put just one sacrificial layer on the bottom. So this is just a layer that we sticked it onto the table. So, you know, if there are some irregularities, and so this is kind of like a sacrificial material. Now, after that, what you would do is, so we would just lay the material. So we have a roll here. So from where I'm standing, I am handling the roll. So the roll looks like what we saw earlier, and you just roll the material onto the table and lay them one over the other. So here we lay the first layer, and then you just fold and lay another two layers. So one on top of the other. So we are just trying to save some time. So overall, we have 3 petals being laid all together right now. And we just repeat that again and again. So I think while we were making this, we planned to make about 2 envelopes. So one was a backup. So we laid it probably 2 or 3 times. So I think it was 2 backup and 1 actual envelope. So we laid it 3 times. So there would be a total of 12 petals, 4 per airship. So this is the next step. So we lay the petal. So this is that petal template that I was talking about. So you get a 1:1 print and then lay it on top of this. So you have about 4 and another 8. So a total of 12 petals, 12 layers of MPET under the template. So you would be cutting 12 petals at once. Okay. So this is the template. You lay it on top of it, and you just make sure that it's properly sticked onto the material. And the next thing is just cutting all the petals. So you just cut the petals like this. So again, I have to remind you, this is a very, very delicate material. It's about 30 microns thick, very thin. So which means you have to be careful while applying pressure while you cut. So I would say maybe practice on small bits of material before you actually use a cutter on the petal, on the actual petal. So that way you know how much force you need to apply while cutting the petals. So here, when we are cutting this, we are also cutting the template. So you see there is this white extra paper that you have on the sides. So even that is being cut. So we just are traversing the black line on the template. So that's what we are doing. So you basically just try to cut all the layers at once. So you would have to apply enough pressure to cut all the 12 layers. And also be careful not to apply too much force and not cut it too quickly, because that would then damage your petal. Okay, so once you have the petal cut, the next thing is you have to pick all the petals and just lay them all together. So this is the last 4 petals. So you see, you can clearly see here that we have actually joined 2 tables. So there is, these are basically work tables where you, in our lab, we keep the PC here, and you have these 2 holes. So basically, this is the desktop station. Okay, so it's not a very good idea to have the cuts wherever you have these, edges, because then it would damage your petal while you're cutting it. So you have to be very careful while you place the template, so as to not to encounter abrupt changes in the surface. Okay, so we remove this all the layers that we have. Now this is something which is not exactly mandatory, but there are other things that you can do. But this is something that I would suggest would help you in making a better envelope. So what we are doing right now is laying a layer of linoleum. So this material that you see, that is linoleum, and that material is typically used for flooring. So the blue material that you see, it's that kind of material. So the reason why we are laying linoleum here is it's because it's heat resistant, and it also gives us a smooth surface while we are sealing the petals together. So that's the idea behind laying up the linoleum sheet on top of the table. So yeah, you could also use glass as a base, but having such a big, huge glass is then another problem. How do you handle it? And it also becomes expensive. But let's say if you don't have anything, you could just do with the table, but make sure you have some kind of insulation on top of your table, because if let's say you have sun mica on the table, it's going to get damaged. On a wood table, maybe you can keep a layer of some kind of heat resistant insulation material. So this is easy to obtain. However, linoleum, you can look at these materials on India Mart. Even the envelope material you would get on India Mart near your locality. So that is the best way to find materials for these things. So we just attach this on the surface. There's a question on Q&A. So what special equipment is needed to fabricate the envelope and airship as a whole? Can it be easily made at home? Chaitanya Bansal, yes, it can be made at home. That is in fact what I'm going to talk about in the next few slides. So you just lay them up here. So this is the base layer. So we did not lay it when we had to cut, because if you actually lay this material and then cut your petals, you would end up cutting the base material as well. So we did not want to do that. So that's the reason why we just lay it after we cut the petals. Okay, let's go ahead with the next thing. So the next thing you want to do is sort the petals. So what we did here is we have this first petal already put on the base material that's on the table. So you see in this material, the shiny part is the non-sealable part, and the less shiny part. So this is kind of not so shiny part. It's whitish in nature. So this is the sealable part. Okay. So we lay it in such a way that the sealable part is facing upward. That's the base petal. And then what we have done is we have folded the next two petals. You see, we have folded them in the middle. So we keep it on top of this like this. So it's like folding the petal from the center line and laying it over the base petal. Okay, again, it's the sealable part which is facing up. So when you are putting the petals together, it should be such that the sealable parts are coming in contact with one another. Otherwise, you won't be able to seal. If the sealable part is coming in contact with a non-sealable layer, then you cannot you cannot actually seal the petals together. Okay. So there is a reason why we put two halves like that. So you see, there is one half, and then there is the other half that we had put. Okay, and then okay, sorry, somewhere over here. Yeah, and then what we did was this is the last petal. So do we wait? Yeah, here. So the last petal, this is the fourth petal. We put it in a way that the sealable layer is facing downward. So the shiny part is up. Okay, so now it's such that all the sealable sides of the envelope are coming in contact with one another, and the non-sealable parts are in the outer sides. Okay. So this is how we do it. And now you make sure that the petal sticks to the base plate very firmly. It doesn't move when you are going to do the sealing. Okay. So I'm cutting a piece from the side and I'm keeping it aside. If you're looking at me, we will tell you why we did that later on. So once the petal is put, okay, it's stick properly onto the table. The next thing we want to do is seal. So there are a couple of ways you can seal the envelope. So a couple of them, butt joint, then you have a lap joint, and then cusp joint. So butt joint is something like this. So you, when you would have to go for butt joint, uh, you will have the envelopes in such a way that you have one sealable sealable side facing up, and the non-sealable facing, and the other one would be the opposite. So sealable, non-sealable, sealable, non-sealable in that way. So when you are actually attaching it, uh, it needs to be in a way that, if this is the sealable part and this is the sealable part and this is non-sealable. So for butt joint, it should be like this. So you see that one side is non-sealable and the other side is sealable. That's how you would see when the envelope is blown up. Lap joint, on the other hand, requires another extra piece. So you just basically lay them up together, and then you have another material which is on top of them. So that's lap joint. Cusp joint is basically you paste it like this. So you have two envelopes, both sides sealable, and then they come together like this. So basically that is cusp joint. So what we will be choosing is cusp joint, and the way to seal the materials would be these two methods that would be that could be used for making the sealing the petals together. So one is impulse sealing machine. So this is the machine that conventionally people used to pack food. So the packet of Lays or even a packet of chips that you see, they are basically sealed on such machines. So if you buy, whenever you buy a packet of chips next time, have a look at the seal there. So it's basically heat sealed, and it's one of these machines that would be doing that. The other option, which is which would answer one of the participants' question, is basically use an electric iron, a normal conventional electric iron that you use to press your clothes. You can use to seal the material as well. Only one thing that we would recommend is to have a heavier weight electric iron, and uh, it should be in a way that you need to figure out what heat settings you need to work with. So you basically need to have this kind of a knob, so you can also adjust the heat settings of the electric iron that you have. So in this particular method, we are going to use electric iron. Professor Pant, I think your audio is on not on mute.
Yeah, go ahead. Sorry.
Yeah, all right. So we will be using electric iron to seal the petals together. So let's see how it goes. So this is a close-up shot of how the envelope is sealed. So you have to hold them together, and you basically have to move it along the edges. Okay. So once you lay up all the petals, so here what's happening is, the reason why we put the petals in the way that I had shown earlier. So one base petal, and then you have two folded petals, and then the other one on top. So by doing that, we are actually we are doing two seals at once. So this is so when he's moving the iron on top of the petal, we are actually doing two seals at once. Okay. So you basically have to take your time in doing this. So using the iron, it would take about you can say 1 hour to properly seal it. You have to handle it very well. Have to get your hands steady on the envelope to get a smooth finish. Also, I want you to note the heat settings. So for us, it was the middle option that worked in the knob. Okay, for the heat. So it might be different for the iron that you have. Let me see. There are some questions. So for aerostat, which is the strong. Okay, let me answer those questions after a bit. I will answer them after a bit. So once you move the iron on top of this, you basically are making sure you're basically sealing the petals together. Okay, you would have to do multiple passes. So that's what we are doing here. That's just to ensure that the seals are well done. Okay. So this is how you would seal. All right. So let me take the questions now. For aerostat, which sealing do you suggest? Which is a strong joint, but lap or cusp? So for aerostat, it depends on the size that you want to build and also the material that you're using. So if you're making a small aerostat, you can just go ahead with the electric iron and make an aerostat. But if you want to make a big one, then your material would change. Then you would have to use something a bit more uh, elegant, like radio frequency sealing if you're using PVC or polyurethane. And you can also use adhesives if you're using polyurethane. There are some PU adhesives that you can use. So then there is another question that butt joint you're showing is actually the lap joint and the lap joint is the butt joint. I am not sure that is right, but yeah, you can maybe have a look and let me know. All right. So why are there two foldable layers in the base plate and the top layers? So this is because we wanted to seal two petals at once. So that was the reason. So let me go back here, petal sorting. So, okay, so let's see, let's look at the first petal. Okay, so the base petal that you have, so you see that the entire, that portion is basically sealable. Okay, so you place another, so once that is done, okay, sorry, yeah, here, so you place the half here. So the reason is when you actually blow air into this or even a gas, so it would basically open up. Okay, if it is folded, it would just open up like this. So that's the reason why we keep it like that, folded in between. So you can actually try this out on paper. So what you can do is, cut the petal shapes very approximately. Try to get this form. So you have to mark the sealable and the non-sealable part on the paper, and place it like this, and then you apply the glue on the edges, and then when you blow it, it actually takes the shape of the envelope. So that is the reason why we want to place it in this fashion. Okay. It also would not damage your envelope while you're sealing it, because then you would have to turn it over and over again. So if you're doing it one seal at a time, it means that you have to turn your envelope every now and then. Okay, I think that answers the question on why that. So the next one is the nozzle. So of course, once you have done the sealing of the envelope, you need to also be able to fill it. So that is why we need a nozzle. So this is what I was doing earlier when I said I was cutting a piece of material. So this, you basically are cutting the a piece of the same material, MPET. So you get this piece. Okay. So you put it in you cut it very nicely, and then so you have this. So this is basically a rectangular strip. Then you fold it. Okay. And now you would seal at the edges. You basically seal at the edges. Okay. So this is a double pass. So we are ensuring that the seal is firm. So once you are done with the sealing, how would you actually attach this part? So as if you remember, I told you that the shiny part is not the sealable part. So it's the white, this less shinier part, that's the sealable one, the polyethylene layer. Okay, so what we need to do is we need to turn this pipe, the pipe that we just made, inside out. So how do we do this? We would basically insert a rope, string, basically get it on the other side. So you basically drag the string on the other side. Oops. Okay, so you have the string over here. So once you have the string, you would want to attach it to the end of the pipe, the nozzle that you just created. So okay, I just stick it with a tape. You can use any kind of tape to stick that thread, and then you pull the thread from the other side. So that way you are basically just turning it inside out. So now what happens is the shiny material, it's on the inside, and the adhesive layer or the sealable layer, that's on the outer side. And there you go. So you just pull it all the way out, and then you have this sealable part on the outer part, on the outside. So now you have the side which you can work with and which you can put in between the petal, in between the petal welds, and you can have the nozzle there. So here is your nozzle. You can remove the thread after you're done because you don't need it anymore. Okay, there is your nozzle. The next thing you want to do is seal the nozzle, and you would basically place it towards the tail and towards the bottom petal. So you basically put it in between two petal seals. You just put the nozzle inside, and you just stick it with some tape so it stays there in place. So we're using masking tape to make sure that it doesn't move when we are sealing. So this is before we actually start sealing the petals. Okay, so I'm putting a layer of butter paper or tracing paper, as you may call it. So on top of this, so that way when I move the electric iron on top of the material, it doesn't stick, because you know the nozzle has the sealable part sticking outside. So what would happen if you move the electric iron on top of it is it would just stick to it. It would damage the surface of your electric iron. So that's why we are putting this butter paper on top of it. You make sure that it stays there in place by using tapes. And next, what you do is you just move the electric iron on top of it. So you just move the iron on top of it, and you just seal it that way. So you would have to be very careful, and maybe you have to apply a little extra pressure while you're sealing the nozzle, because there are more layers there. So the heat needs to penetrate all the way down. So you just move, have a couple of passes over the nozzle, and you have it sealed. Okay, so basically you are able to seal the whole petal now by these methods. Now, once you have the entire sealing done for all the joints, you would basically want to check if there is any leakage. So the first thing that we will do is we will fill it with air, and we would use this kind of pump, an electric air pump. So this is very cheap. You will get it for about 500 Indian rupees. You would get this on Amazon. This is typically used for inflating air mattresses, inflatable toys, and things like that. So there was one question. Is there any other way of doing the sealing, like using any particular adhesive? Yes, but not for metallized polyethylene. For metallized polyethylene, heat sealing is the best thing that works out. It depends on the material that you have. Uh, so depending on the material, you can go for adhesives. As I mentioned, if you go with PU coated nylon, you could use PU adhesives. Although you have to be very clear, very careful while using adhesives because adhesives also take up weight. So you need to be very careful while using adhesives. So if you say use 100 grams of adhesives, it would just add 100 grams of weight to your airship. So let's go ahead with the inflation. So what Raman has done is he has plugged in the nozzle to the air compressor, air pump, and we are just blowing it up. So I'm making sure that there is no leakage at the nozzle, and we just fill air, inflate it. So you see, this is how. So those folds they basically open up now. I don't know if if it is very clear, but here around this point, around the center line, there is this faint line. So that is why that was. This is the folded petal in between. This is the reason why we had to do it. So when this is folded, so basically this seal and this seal, they both got sealed together at once. So that is why we folded here at the center. Okay, and we placed it the way we placed it because that way we were able to seal it much quickly. Okay, so it's all inflated now. And Raman just folded the nozzle there and he put some tape on it so the air doesn't leak out. So that's the reason why you would want to have a very long nozzle, so that way you can fold it up and then apply tapes on it so it doesn't leak out. So that's the way you're ensuring that the gas is inside. Okay, so once you're done with inflation, I will show you the most sophisticated way of measuring leaks using a very sophisticated sensor, and that sensor would be your hand. So I'm just moving my hand on top of these seals to see where exactly there is leakage, if there is any leakage over the seal. So you have to be sure that the first thing that is very likely to leak is the seal. So that's why here I'm checking the leaks first. So Raman is holding the envelope a little pressed like that because we want to know whether the air is gushing out, and that happens only when the pressure is high inside the envelope. So that's the reason why he was holding it tightly. So the pressure inside is higher. So I think, yeah, for this envelope, yeah, there was a leak on the petal itself. Yeah, so there was a leak over the petal. So there is this small dot here. It's basically, I could feel some air moving out. So we are using a sellotape to just patch that particular leak. So this is how you would repair your envelope. Just apply a patch and there you go. As simple as that. So there is a question how to make king go. So well, if you if there is enough envelope pressure inside, internal gas pressure, then there won't be any kink. That's what would maintain the shape of the envelope. Can you use soap or shampoo to check for leaks like a puncture wala? Yes, you can, but unfortunately, the thing is you would have to apply it all over your envelope. That's going to make it messy. Also, if you want to dip it inside a bucket, it's not really a good idea because finding such a big bucket would be a real challenge. So maybe you'll have to take it to the swimming pool and dip it all the way down, like, you know, the puncture walas. But it's not a very good idea because when you want to do that, you would have to carry that whole thing to another place and, you know, dip it. It's also very difficult because of the buoyancy. The difference between densities of water and air is high. Soap, however, can work, but it's not recommended because you can usually feel the leaks with your hands. There are other methods as well, but that would require you to have some basically some extra equipments like the leaks, helium leak detector, things like that. Another way you could know whether there is a leak or not is to inflate your envelope and leave it overnight. So you leave it overnight. So let's say you wait for 24 hours. If there is any leakage, or if you see that the pressure inside the envelope has gone down, then it is confirmed that there is a leak. If significantly it's down, okay. Uh, is there any alternative way for leak sealing? It depends on the material. Uh, so if let's say you're using some kind of translucent material, you can use a light bulb, a very bright light bulb in the front, and see where there are holes. You know, if it is some kind of a colored material, then you would see that, okay, from one end there is some kind of a light poking out in a dark room, and that's how you know that there is a leak. That is one way in which the previous LTA lab members had come up with. And alternative, and I already told you about the helium leak detector. So we have this helium leak detector. So what we do is we fill almost entirely the envelope with air, and then we put a tiny bit of helium inside. Now helium is a noble gas, so you can mix it with air. So what we do is then we move that sniffer. So there is kind of like a nozzle, and then you move it all around the envelope to see if there is some kind of leakage. So the leak detector would detect that. However, that again would invite a lot of trouble. So the easiest way is just using your hands. Trust me on this. It's the easiest way. I've tried other methods, but this is the one. You have to be really slow about it. Uh, so you see that this is actually in 8x speed. So I've been very slow while I was checking for the leaks. Okay. Can we use plastic tap for joining four circuits instead of? Uh, I don't know.
What he means is tape, not tap, tape, plastic tape, cello tape.
No, you cannot use plastic tape. I think you're referring to the cello tape. You cannot use them because if you want to put it, you can try it out yourself and try to inflate it with air. Even air, not just helium or hydrogen, can gush out of the tiniest of places. So there would be a lot of wrinkles on top of the see. When you look at this, there are a lot of wrinkles, and when you apply tape on top of it, there would be airways in between, through which the air could gush out. So that's why you don't use tapes. However, if you want to cover the seals, you can, after sealing, you can apply the sellotape. So that way you have a nicer looking envelope. In fact, I used to do for a couple of my airships as well. Sorry. Yeah, so Girish asks, do you leave the joint cups on the outside, or is there a way to turn the envelope inside out? There is a way. So just like you did it for the nozzle, you can do it. You just leave one end open. But then the tricky problem is you would have to seal the open end. So that becomes a little bit tricky, and that's why we usually don't go for that, because when we try to do that, in our experience, it usually ends up having a lot of leakage at that particular point. So we usually don't do it, but you can do it. It's not that you cannot. If you want, you can cover the cusp joints by applying tape on top of it. You just apply some lightweight tape, so that would hide the joint and also give airship a better look. Okay, so let's move ahead. So I've already discussed about this air pump that we use to inflate the envelope. Now the next thing that we want to discuss are the hooks, because as of now the envelope has nothing that you can mount something on. So you need to have some kind of hooks using which you can attach items onto it, like the gondola the fins, and any other thing you want to attach. So this is one way of doing it. This is a very simple way, and let me show you what it is. So that is a duct tape, okay, or it basically has a layer of fiber on it, and also the adhesive is quite strong. It's very strong adhesive. So what we do is we take this, we put the adhesive side up on the table, then we cut a smaller piece and make a band-aid out of it. So here you see you have the white ends are the adhesive ones, and the silver one is just sticked onto it. So that side is not adhesive anymore. And then we just cut it into half, and now you have basically two band-aids. Okay, and this band-aid is the hook. I want to talk about that blue line as well. So this is another airship on which I'm attaching the hook. So you basically attach it, and yeah, you see basically it's attached like this. So you have a C there. It's kind of like this. So here is where your non-adhesive part would be, and this is the red one. Here is the adhesive part. So this is how it would stick, and you can basically put anything over here. So you can pass a rope through it, or even a pipe, or whatever you want to do. It's basically a hook for you. Okay. So the blue line here that you see is that tape that I was talking about. So this is again a cusp joint, and on top of it we put a blue tape because we wanted to hide the joints. So this would just give a nicer look to the airship. You can also take your pick and also make it a little more smoother, more aerodynamic, because when the cusps are hanging out, the seals are hanging out. It's kind of additional drag. So if you just stick them onto the envelope, it just remains smooth. It's not mandatory, however. So once the hooks are done, again you can go. You come up with different methods of making hooks. So this is just one of the convenient ways that we use. What kind of tape is that? It's a duct tape. So let me just also write that. DUCT, duct tape. So you can just look it up on Amazon and you would be able to get this. Okay, so the next and the final step is to inflate it with helium. And this is the cylinder that we have, and this is the regulator. So once the regulator is fastened to the cylinder, we have this open closed valve. We connect it the same way as we connected the okay, so there is a question on hooks. So let me just take that before I talk about helium. How much weight can the hooks handle? So it would be rated on the duct tape specifications. Usually, so it depends on also how much surface area is being stuck onto the envelope. So let's say you have a rating of, so basically it would come something like 1 kg weight of half kg support. So that would be marked on your duct tape. Okay, so typically if you have enough adhesion, enough area region for adhesion, you can take up to maybe 200 to 300 grams of weight on that. Not individually, but maybe on a couple of, say four of them, you would be able to take about 300, 400 grams. Okay, so let's look at the helium bit. So you have to, once the air is removed from the envelope, you basically would want to inflate it with helium. And that's what we are doing. We put the nozzle, connect the nozzle of the cylinder to that of the envelope. And there you see it's very slowly increasing. So Raman is constantly controlling the pressure, so that way we have a control of how much gas is being released into the envelope. Okay, I want to show you something here. So have a look at these seals. So here you see 4 seals. So this is these seals are put here to attach the gondola. Okay. So this is the bottom petal. So going ahead with the video. We'll talk about that later in the further sessions. Oh, here you see the example of kink here. So the reason why this kinking happens is because helium tends to go upwards, right? Because it's a lighter than air gas. So what happens is two independent bodies of gases form here. So there is one and at the one body being formed at the tail end and one body being formed at the head. So both of these have the tendency of moving upward. So that's the reason why you get this kind of shape. So, but when there is enough pressure, both of these gas bodies are connected and the kink disappears. So that's why maintaining that internal pressure is important. It's very difficult to handle it while you're feeling helium because your envelope is constantly trying to go up. See, without any effort, it's just moving upward, and I'm holding it down. And on the other side, Raman is also holding it down. So what I'm doing right now is I'm using the gondola hooks to fasten a thread there, and tied to a weight on the ground. So that's a 5 kilo weight. So I just tied it, and yeah, so that the envelope stays there. So we'll talk about this fins part later on. So don't worry about the fins, how it was mounted there. So yeah, so basically you just put the ropes through the hooks, and then you just fasten it to the ground so it stays uh, grounded. That's about what I wanted to discuss about envelope fabrication. If there are any questions, maybe you can ask them on the Q&A. I've answered.
Yeah, Sohan, there is one question that you made a nozzle, but then how do you close the nozzle?
Oh, we just fold it. So here, let me show you this part. So look at what Raman is doing. So Raman is this guy on black. So what he just did is just, so you have this envelope, you just fold it into a curl. So when you fold it, it basically is forming several edges, and that is basically how you make sure that it doesn't gush out. That's the reason why the nozzle is also very long. So you have multiple folds.
Yeah, so you fold it multiple times and then just stick it with tape.
Yes.
That will be enough because the pressure is not too much, so it will not force open.
Yes. Okay, I don't think there are any other questions. Oh, there is one question. So I think the tape is already answered.
I will answer the question from Chaitanya about the, see, whatever we are showing you is being available on YouTube in a live session, and it will be available thereafter. Okay, so there is absolutely no need for you to worry and to ask us to ask for the PPT. We cannot share the PPT with you, but there are, as I said, this is being webcast. It will be available for the foreseeable future on YouTube. Are we not doing rough CG marking on the envelope? Yeah, you should be able to, you should do that.
Sir, I would like to answer that.
Yeah.
Okay. So we are not doing CG marking. You are not, basically, you wouldn't want to do CG marking because that is not of concern to us. What is of concern to us is the center of volume. In fact, we did estimate where the center of volume is, and that I can show you here. Sorry, not here. Yeah, inflation with helium. So when I am actually sealing it, well, I'm actually mooring it to the ground. So, okay, sorry. There should be a point where you are able to see how it is resting. So yeah, this point basically from where the thread is coming, it's actually the center of volume, and you're precisely able to calculate it. There is a mathematical formula for modified GNVR. However, again, you can also use calculus. You can just use calculus to calculate where the center of volume for any given shape would be. So basically, it would be the area where it would coincide with the CG of the envelope, bare envelope. You consider envelope as a solid body, and if you are able to calculate the CG, you can also use SolidWorks for that. That is basically also the center of volume of the airship and the envelope. So that is the point at which we are basically mooring the airship. Uh, yeah, I think that is answered. Ed, yes, sir. I'm done with the presentation. Thank you for your attention. Over to you, Professor Parikh.
I think we have one. I think we have one hand raised.
I've told her that if she has a question, she should ask in the chat window, in the question answer window. You know, many people raise their hand sometimes by mistake also. So I don't want to. If there is anything, you please ask in the Q&A session, and if we want to hear you, we will allow you to speak. Don't worry. But just tell us what you want in the Q&A. Okay. We'll wait for about a minute to take questions in this. Any question that you have. Otherwise, I'm going to launch a short poll. I'm going to launch a short poll, and I would request all the participants to please take part in the poll. So day 3, session 1. Poll has been launched. Kindly answer the questions. There are just 3 questions.
Sir, there is a question by Dhanvin Mehta. So I would like to answer that because it's an important one. So the question is, how much should we inflate the envelope? That's a very good question. So the general rule is we usually check for the pressure in the nose and the tail, because that's usually the pressure that is usually the points that gets filled out at the end. So you would actually see if those points are getting tighter, and also as you increase the pressure, the wrinkles on the envelope would disappear. So if you recall the video that I showed on inflation, you can check on the YouTube again. The wrinkles actually disappear when you are inflating it more and more. So the idea is that you will only inflate it to a point where you can feel that there is not a lot of pressure inside. It shouldn't be very, very tightly packed, because if you do that, then your envelope is going to burst. We have had this incident a lot many times when we just were being over ambitious about making the envelope tightly packed with gas, but that would just cause the envelope to rupture. So I would advise against blowing it too much, inflating it too much. So take step by step. So you just uh, inflate it to a point where the tail and the nose are not very firm, but slightly firm. The other question is 30K per run using helium. No, 30K per run is the 30K was the expense that I told is an estimate of the total budget that we would have, that we would need if you were to operate with all the costs included, the avionics, the transmitter, and everything included, the cost of the helium as well. The cost of helium would depend on the price that you're paying per meter cube of helium. So this particular airship is about 0.7 meter cube, approximately 1 meter cube. So if you're using helium, that would be, I think, about 3 to 4,000 rupees per flight trial for filling it once. So I think the current running rate for helium is
So I'm going to talk about it. Don't worry. I'm going to talk about all that in the next one.
Okay,
So
sure, sir.
see, costing cannot be just discussed like this. Okay, there are, as I mentioned, many things about costing which have to. So in the end today, we have a 45-minute session for answering such questions. Okay, so let's not worry about costing questions right now. See, the question that you ask should be relevant to what has been discussed in the presentation. That is my request. Okay, we have a special session today for all the other questions. Okay. All right. So around 84% of the people, 112 people, 113 have taken part in the poll right now. I am going to give you one more minute because we are a little bit slow today. We are half an hour behind schedule already. So I am going to give you another 1 minute only, and then I'm going to stop the poll. And these polls also are short bio breaks for people. So you can answer the poll and then take a short bio break, and we will resume after the poll is over. Okay. So I'm going to now stop the poll. Right. Let me share the results with you. So the material that was used for making the envelope of the demo airship was metallized polyethylene, MPE. I don't know why people have answered polyurethane with nylon and LDPE. Which kind of joint was used in sealing the petal for demo airship? I think it was the cusp joint, right, Sohan?
Yes, sir. Yes.
Yeah. So it was a cusp joint. Then which equipment was used for sealing the envelope? Now, if you guys are just watching the presentation and the video, you would know that we have not used any impulse heat sealing machine or any radio frequency sealing machine or soldering iron. Okay, I don't know. This seems to be a miscreant who is answering soldering iron. Electric iron is the correct answer, which most of you have shared. Okay, so I'll stop sharing. And I would like to now pass on the control to Professor Dhanil Shukla for the next session, which is on the gondola and fin. So over to you, Dhanil.
Yes, thank you, Professor Pant. So after making the envelope and filling the gas, so other thing that we need to look into is the peripherals, which are the gondola and the fins. So Okay, let me take a pointer here. So here we see these are a few airship models, and so this envelope is something that you just saw how to make in the previous presentation. And the other things that you see attached to this envelopes are like some structures below it, that is the gondola, and you see some fins here. So 1, 2, 3, and of course one of it is going to be behind it. So similarly, you see in the second model as well as the third model. So what is the role of gondola and what is the role of the fin? So gondola is where your payload, your maybe your radio control and other things are going to sit. And fin is more like for giving direction or directional stability to your aircraft or to your airship. It acts like a wind vane like this. So this is to ensure that your airship always faces towards the moon, and it just gets adjusted to the direction automatically. Okay, and other thing to notice is that in this fin, you do have a popular setting inside, and that popular is for yaw control. And we will look into how to construct these things briefly. Okay. So the next is design of the fins. So this is a typical shape of a fin. Here, S fin refers to the surface area of the fin. B is a span, and CT is chord at the tip, and CR is chord at the root. From basic literature survey, it is found that the area ratio, or basically getting a guidance of how big the area of the fin should be. So that is given by this relation, that is area of the fin upon the max area that has been described earlier, I think in the yesterday's presentation. So that ratio typically ranges in the order of 0.1, 0.2. And one would typically take a value of 0.12. But here in our exercise in this workshop, we're actually not using this particular approach, but instead we are going from the mass balance or mass or a weight budget perspective. So earlier we had set the weight of the fins, like we have budgeted about 100 grams for the weight of the fin. And depending on what material you are using, you can determine how much area you can have for the fin. Okay. And for our demonstration, we are using 3 fins of Depron material. So these 3 fins are going to be the top and the 2 side fins, and the bottom fin is going to be Aeroplan. Why is there a difference in the material? Because the top fins are not going to be carrying anything else, but the bottom fin we are going to put the propeller for yaw control. So that fin has to be stronger. Next, the other things that we have to control is the aspect ratio. So how much should be the B versus the chord length, or determining these dimensions, because so far we have only determined what is the area of the. So aspect ratio, which is defined by B square or span square divided by area of the fin, that typically ranges in the order of 0.7 to 1. And we would like to have value which is somewhere in the middle, that is 0.8. And so we know S fin, so we basically get an idea of what is B square. The next is location ratio, and location ratio basically we are saying that where exactly we are installing the fin. And here L fin refers to the length of the CG of the fin from, like the distance of the CG of the fin from the nose of the airship. And the capital L here is just the total overall length of the airship. So what this says is about 75 to 85% from the nose, you would have the fin located. We'd probably go for center value that is 0.8. So from this, we have an idea of how large the fin should be, what should be its dimensions, and where should it be located. Okay. Any doubts? I'll just quickly check if there are any questions here. Yeah, I don't see any, so I'll proceed from this point. So here is a quick video on how the fin was made. So I'll just comment on what it is, what's going on. So here you see these 3-4 strips. So these strips are of Dipron material, and on that you are actually sticking some two-sided tape. So this two-sided tape will be used to stick the fin also to the base, and this base will go on the envelope. We will see that soon. So we have these bases made. We have removed the upper part of the two-sided tape so that the fin can stick to it. We are just sticking this electron fins to the bases. So 3 done, and the last one is next. So here, so the 3 fins that we just saw are for the top and the 2 sides, and this particular one, which is of aeroplan, is it's for the lower fin. And here, if we see that, let me see, you can zoom in. We do see some holes and empty space. So these holes are going to be used for mounting the brushless DC motors or whatever motor you find. So it's so you'd mount the motor here, and the rest of open spaces so that the propeller has a way to push the air around so that it is actually effective. Okay. So in this particular case, this material has been cut using laser cutting machine, but this is not necessary. You can always use something else. So for instance, Depron and Aeroply fins could have been replaced by corrugated sheet, like the things that you find boxes of. And maybe you can cut these shapes using hand cutter or scissor or something, but just make sure to do a good job at making this. At least the lower fin should be sturdy enough to hold the motor. Okay. So we basically stuck this one too. And beyond that, we are trying to strengthen the bond between the fin and the base by adding more Teflon material and then using hot glue gun to glue the sides and the base. We do the same thing for all the fins. Okay, so here what we see is it's some kind of frugal innovation. So these things are actually the ends of riffles or pen riffles, mostly ink pen riffles. So we wanted some tubes, and this seemed to be easily available. So we have cut the riffles to small pieces to have this kind of tubular material available to us. So what we're doing next is drilling into the fins over the top 2 locations and inserting the riffles. This is done so that later when we put some guide wire through it or some fishing line through it for better strength, the Teflon material does not get cut, because riffle plastic is going to be stronger than the Teflon material. Similarly, we do it with aeroply fins. Okay. So next, what we're doing is we are attaching the brushless DC motor to the center of this fin. So in the left hand, we have the motor, and using the right hand and the Allen key, just strike it there. Okay, so we have the motor in place, and we have the propeller also, and propeller is also tightened using um, another element. Because depending on what propeller you're using, there are different ways in which you can this attachment is going to be made. All right, so we are done making the fins. Next step is to mount the fins on the envelope. And before we do that, it is important to do markings on the envelope so that we know exactly where to place the fins. It could be done when it's best to be for it to be done when the aerostat is deflated, I think, because you have more control over making such kind of lines. Once it is inflated, it's difficult to make a straight line and take the measurements. So we have 4 such marks. One is, I believe you are able to see one such mark here, this green line. And there are 4 other such marks around the envelope on each petal. Also notice that these marks have been made between the sealing locations. So there's one sealing location here, the other one is somewhere else, like below here. And we want to place fins right in the middle. Okay, so I'll play this video as well. Other thing I'd like you to notice is here are the hooks or the things that Dr. Sohan mentioned that you can make using the duct tape. So these ones are going to be used for fastening the fins so that the fins don't fall off. So here we just have tape, got the fin in location using double-sided tape, but that's not going to be enough. So we then place fishing line or very thin wire, which you may not be able to see in the hand, but you can. Let me see if I can pause it and show. So these thin lines, if you're able to see them, these are being used to fasten this fin with hooks on the sides, on the ridges, and ridge on this side as well as the opposite side. Okay. You just have to learn how to tie the knots, and the motive is to have the fins like properly placed and perpendicular to the envelope. Other thing would be nice to notice is that this exercise was done when the envelope was filled with air and not helium. You can see
Dhanil, sorry for interrupting, but Dhanil, your voice is cracking slightly. Your audio seems to be cracking. See if you can do something about it.
Yes, I might have some internet issues.
Yeah, it is okay.
All right. Should I just stop my video just in case?
Yeah, that is better. Put your
issue?
video off. Put your video off. It will be better.
Sure. Yeah, I think there's some problem with internet for the past 2 hours here. All right. Has my voice become any better?
Yeah, there is some improvement. So better put your video off. Some improvement is there. Yes, please go ahead.
Okay. Yeah, so maybe if I was not audible for some time, all I was trying to say here is that we are tying the fin to the envelope properly using the hooks. And we are doing so when the envelope has been filled using air, filled with air and not helium, so that it's easier to handle it. So this is for one fin. Similarly, you do for the others. And I'm just skipping the video, but you get the idea that you have put multiple fins on the envelope. Okay. So the next thing is gondola. Gondola, as I described earlier, it's the structure on which you would have other propellers for moving forward or backward. You'll have another. So you'll have propellers here for moving forward or backward. You will have your telemetry, which means your radio control, battery, maybe one more motor propeller set here for increasing or decreasing the altitude. So there are many ways in which you can make gondola, as been told to you before, but this has been the design which is there in this workshop. So feel free to innovate. You can make this out of cardboard or anything that is stiff enough and can carry the weight of everything that you need to carry. But what we used was 3D printed, and this was the model. Okay. So these are some photographs of the gondola. And along with the gondola, we have this propellers installed to it. So of course, you would install this electronics and propellers to the gondola before you attach gondola to your airship. Okay, so let me show how exactly was this attached. Here in this diagram, you can see there are two tubular holes through the gondola, and through these tubes, there were two carbon fiber rods that were passed through it, and those rods were somewhat long enough so that one could tape the rods to the envelope. Here you see that the duct tape has been applied to the carbon fiber rods, and through this tape, the carbon fiber rods have been stuck to the envelope, and hence the gondola stays in place. This is necessary because gondola is going to be one of the heaviest things that you attach to the envelope. So it is important that it sticks to it. In case the gondola falls off, then basically your aerostat or the rest of your envelope is too light, and it will just climb out of your control. So we do this, and so here in some other view. Okay, so if you look at the image on the right, this is where you can see how the duct tape was used to stick the carbon fiber rods to the envelope. Next, here in this image, you see two propellers facing forward. They are for forward and backward thrusts for moving the airship forward or backward. And here you have another propeller, which is for altitude change. Okay. So here is a video for gondola attachment. Okay, I'm seeing a question. The question is, how will we be making connections for avionics? So that one will be covered in the next lecture. I see another question, that is, will you please show how propellers and motors, transmitters and stuff? Okay, so that again will be covered soon. Yeah, currently I'm just covering how to attach it and what goes inside the gondola. It will be covered by Raman in the next lecture. So in gondola attachment, here we see we have a airship envelope. Okay, sorry. It seems my PowerPoint has crashed. Just give me a minute.
Sir Shukla, maybe you can play it on your video player, this video, if you have them downloaded.
Just a minute. Yeah, I think it's, yeah. I think I'm back here. All right. So in the video, uh, basically, as I described earlier using the photographs, the gondola was stuck using the duct tapes and the carbon fiber rods. And beyond that, you want to strengthen the bonds even further. So what is being done is the fishing lines are being tied from gondola to the more hooks, to these other hooks we see. Let me just find a good opportunity. I think the PowerPoints here. Yes. So let me point out that these hooks that we see here on the sides, there are on both the sides. So we are attaching the fishing lines from gondola to these, so that in case there is these tapes fail, then you still have additional support. So we definitely want to make sure that the gondola does not fall off anytime during the flight. Okay. I think rest of the video is just inserting more fishing line through the and if you're wondering where is this fishing line being connected to, let me just show that here. There were multiple holes provided in this design so that you have some place to thread it through. Okay. So yeah, so by the end of this activity, you have gondola and the fins attached to your envelope. So any questions on what we just covered? So how is gondola location determined? So one thing is when you were designing your gondola, like when you were designing your airship and you were doing all these calculations, you already had an estimate of where to expect the CG to be. And for static stability, where should you have the gondola? So your first guess will start from there. And if you need to adjust it here a bit here and there, that is also okay. But understand that whatever you do, it's going to like undoing a gondola that has been fixed at a location that will probably damage the rest of the aerostat. So it's a good idea to plan the location of gondola before even you start working on anything on the airship physically. Okay, any other questions?
Yeah, friends. So see, these questions are meant to clarify your doubts. So don't hesitate. If you have queries or questions, you can ask. And also, I would like to inform you that the videos that you saw today are also going to be made available on our YouTube channel so that you can watch them at leisure. Because of the connectivity issue, you could not probably see some of the videos, but you will be able to see them. So I think, Sohan, later on, we can see how to release it.
Yes, sir.
Anyway, there is a proposal to make a proper YouTube video about this particular activity. Okay. Any specific formula for exactly locating the gondola? So Aditya, what you do basically is do a center of gravity analysis. Note down the weight of every item and where it is supposed to be, what is the CG of each item. And then you can calculate by doing a simple CG analysis as to where the gondola can be located. And I think some mention was made by Sohan in his presentation. Okay, time for another quick round of questions. I'm going to launch the poll now. So day 3, session 2. And the panelists can also take part in this poll. So I'm launching the poll. Please answer the questions. So this is a short break as well as a feedback, as well as a poll session. Okay, there are three questions. Spursh wants to know about angle of attack and angle of inclination. Okay, so one is answering. Since it is airship for indoor flight, is it likely to do away with fins? Ravan, you can do away with fins, but you do need some stability. So it is better if you have fins so that it goes in a straight line. Vignesh Kailas has a question. If we make a rigid airship and make inside vacuum and hence make it lighter, yes, we can do it, Vignesh, but you have to get a structure which can handle vacuum. If you can do that in a lightweight structure, you are game to this. So nothing is very foolish in this. It's a very valid question. In fact, I have an associate in Germany working exactly on this concept. Structural analysis of a shell which can handle the load of vacuum and still be light enough to make it worthwhile. So it's not a stupid question. Okay, I think I will wait for maybe a minute max for the poll to be completed. There are just three questions, friends. It's nothing very great. So there are only three questions. So please answer quickly so that we can start with our next session, for which Raman Verma is ready. Are the hooks of duct tab for gondola sticky? Yes, one is answering. In case of only two vertical fins, how the pitch is controlled? It cannot be controlled. Harshit Khatri, no, it can't be controlled. If you want to control the pitch, you need two horizontal fins minimum. Okay, I'm going to stop the poll now. And I'm going to share the results. So the first one is about the size of the fin determined. There are actually two answers for this. One is the historical trend of the aspect ratio of the fin. And the other one is that you determine the surface area within the fixed mass of the mass budget of the fin. Historical trend of the weight of the fin cannot be used. And obviously there are some people who are trying to answer, I would say, foolishly. How are the fins attached to the envelope? There was only one way, fishing line, which many of you have answered. There was no mention of copper wire or steel wire or cotton thread. I don't know how they got these answers. Which of the following can be used to make the gondola of an indoor RC airship? The answer is all four of them. Any material can be used as long as it can hold the avionics. Balsa is lightweight. So I have stopped sharing this one, and I'm going to now invite Raman Verma to share his screen and start talking about the next topic, which is avionics and system integration. Over to you, Raman. Yes, please go ahead.
Good evening, everyone. My name is Raman. I'm a project engineer.
You got to be a bit loud, Raman. Your voice is coming low. Please speak a bit loudly. Go near the mic, maybe.
Hello, everyone. My name is Raman. I'm a project engineer in the LTS Systems Lab. I'll be covering the avionics and the systems integration for this particular airship. So for the forward thrust motor, we're using the iFlight Zing 1204 4500 kV. So let me tell you what the 1204 stands for. This 12 is the stator diameter. Stator is actually, you see, over which the wires are being wound, the internal structure. So the diameter is 12 mm and the stator height is 4 mm. So that is the basic brushless motor nomenclature. 4500 kV, the kV is not a kilovolt, it's a number which signifies that if you spin the motor at 4500 RPM, it will produce 1 volt. Then the propeller that we're using is a 63 prop from Gemfan. When we say a 63, it's a 2.5 inch propeller in inch dimensions. And when we say it's a 2.5 cross 4 cross 3, that would mean the 4 is the number of blades and 3 is the pitch of the propeller. So in this propeller that we're using for forward thrust, we're using a 3-inch pitch with 2.5 inch diameter, which is a 63 equivalent. For the yaw control, we're using the same motor, but for the yaw control, the motor will have dual direction. The motor will be able to spin clockwise as well as counterclockwise. For that, we will be flashing it with a particular firmware. For the vertical thrust motor, we're using a little powerful, which is a 2205. Again, 22 is the diameter of the stator and 5 is the height of the stator. For this, we're using a Gemfan 5030 3D prop. The reason it's a 3D prop is because the airfoil is neutral. That means it will give equal thrust in both the directions. Now, when we come to the electronic speed controller, please notice that for this project, because we want to use it for as a reversible ESC, so it needs to be a BL Heli or a BL Heli S firmware based ESC. Simon K and any other firmware will not be used because the configurator that we're going to use for a reversible firmware is based on a BL Heli firmware. So please notice, in order to reduce the weight of the ESC, there are no capacitors, and as well as there is no onboard battery eliminator circuit, which provide 5 volts to power your servos or any other receiver on board. So that, please notice, you have a positive cable. This is the red one, and a negative cable. And then the white one is the signal, which takes the PWM from the radio receiver, and this black is the ground. And these are the 3 pads over which you will connect your motors. Now, in brushless connections, basically, you can connect any 3 wires at any of these tabs. And if you want to reverse the direction of the motor, you can switch any 2 tabs. That's the basic for how to attach a brushless motor. The reason that we're using the BEC is we want to power the radio receiver, or in case if you want to use a servo, you also need additional power of 5 volts to power your servos. That's why we need an additional UBC. This is rated at 5 volts at 3 amps. Now the battery that we're going to use is a Tattoo 650 mAh 3-cell 11.1 volt LiPo. Now the 650 milliampere hours, like in simple terms, what this means is this particular battery is able to provide 650 milliamps of current for 1 hour, or 0.65 amps for 1 hour. And this discharge rating 0.75C is the maximum. It's a number when you multiply it with the mAh, basically 650 milliampere hour, it will give you the maximum current that it can give. So you can use anywhere from 450 mAh depending on your current draw to all the way up to the weight that you have in your design. But for this design, we're using a 650 mAh 3-cell LiPo. Now we will we will tell you how to flash a bidirectional ESC firmware on the BL Heli ESC. So for this setup, what you will need a F4 based flight controller, basically. The one who are into the FPV drone industry or anybody related to multi-rotors will be aware of the F4 based flight controller. What do you need? You will need a 3-cell battery, 3-cell or a 4-cell, whichever battery that you're using. Okay, you need to power the ESC with the battery, and you need to connect the signal and the ground wire using a jumper to the motor output pin of a flight controller. Generally, a flight controller F4 flight controller will have 4 motor pins for motor 1, motor 2, motor 3, motor 4. That is basically meant for a ESC. So basically, you connect it with the flight controller, power the ESC. Notice that I have not connected the motor here. So this is prior to making the connections, you have to make sure that two of your ESCs, one for the vertical thrust motor and one for the rudder motor, will be bidirectional. So then you connect this with the micro USB cable, so that we go to the configuration section. So for the configuration, we're using a BL Heli configurator, which is an app available on the Google Chrome web store, or you can download it from Google as well. Please notice that it uses BL Heli firmware only. So when you connect the micro USB, you will notice the COM port shown. I'll play this video. So when you connect, it says the directions: connect power to the ESC, which you have already connected. Then you will see a layout like this. Basically, this is your particular series or model number of your ESC. And then here you see the motor direction. You can reverse the motor direction even without switching the two wires, or by connecting to this configurator. Here, what we're going to select is a bidirectional, because we want the motor to spin in both the ways. What I'm doing, the PPM central throttle, it needs to be at 1500, and the maximum throttle, it should be 2000, and minimum should be 1000. After this, you have to write the setup. You can also vary other parameters like startup power. I would recommend for beginners, startup power. So this is how you flash your particular ESC for a bidirectional firmware. Now coming to the radio is basically a kind of a joystick which works wirelessly, so that you can give a command to the airship. So in this particular setup, we're using a FR Sky QX7 transmitter, basically. And let me tell you, if you're into aero modeling or into any other RC related activity, or even if you're not, I'll just tell you very little basics. When this stick moves up and down, it is called the elevator, is generally the channel number 2. When it moves left and right, this is basically the aileron, or the channel number 1. This stick, this doesn't have any spring, basically. So it starts all the way from bottom, goes all the way till up. It has a ratchet movement. So this will be your throttle, which is generally channel number 3, but you can always choose whichever channel that you're comfortable with. And we're using a 4-channel receiver from FR Sky. Basically, we're using these systems because these were available in our lab, and these are very lightweight. You can use any other radio as well. You can use Futaba, you can use even a Fly Sky radio, as long as it operates at 2.4 gigahertz frequency. So this, I will show how you can actually configure your radio. Basically, what we're doing is the forward thrust motor, because we're using 2 motors and 2 ESC, we will assign them to channel number 3. We will assign the vertical thrust motor to channel number 2, and the rudder, basically, we will assign it to channel number 1 for your comfort, but you can always assign the rudder to channel number 4 as well. So basically here I'm showing how I am binding the particular receiver to the radio. Different receiver, different transmitter have a different method of binding, but it's more or less the same. As you can see, the light is steady green. That means it has bound to the transmitter. Now, as we already seen the gondola, so basically this region is the region where we mount our battery. So this is the battery bay. These holes are taken from the data sheet of the motor. Every motor have a data sheet where they mention the dimensions of the mounting holes. So this is the exact holes that were taken from the data sheet. And because 3D printing gives us the exact drawing, so that we know the accuracy is higher in a 3D printed design rather than manual drilling of holes. You can even drill holes manually, but we would recommend a 3D printed gondola. Now, this region is the region where you house your electronic speed controllers and your BEC and your receiver. So upper bay is designed for avionics. The lower bay is designed for ballast or your battery. As you can see in this is your basically your ballast, and behind this is the battery bay. And this particular slot is for the vertical thrust motor. You can notice this being a little bigger battery, a bigger motor, sorry. So the holes vary according to that particular motor. So here we will show you how what are the parts of the gondola, how the gondola looks like after 3D printing it. So these are the protective coverings. These are generally used in small size multi-rotors, generally known as WHOOPs, WHOOPS. So now we will come to the connection diagram. It's very basic. What you're going to do is you will connect all the positive wires of all the 4 ESCs together to the battery connection lead. So every battery has a different kind of a connector. So you will have to get a particular kind of a battery connector. So this 650 mAh battery has a XT30, XT30 connector. So you will have to get a male version of the basically battery connector, to which you will connect all the positive wires together, and you will also connect the positive of the UBEC, and then you will connect all the negative wires together of the ESC. Now, because forward thrust motor, basically, you will be getting the same signal because you want the motor to run at the same RPM when you give the throttle. So there are two ways. Either you can connect both the signal PWM signal together and then feed it into the channel number 3, or you can program a channel number 4 or channel number 5. That's a programming in the radio. But for simplicity, you can join these two signal wires from the thrust motors. You assign it channel number 3, which is your throttle. For the vertical thrust motor, the signal wire will connect to channel number 2, and rudder basically will be connected to channel number 1 in your radio. And you have to make sure, please make sure that the soldering is done properly. No manual joints, please. Please try to solder the joints. And so here you can see I'm trying to connect all the positives together. You can even use a power distribution board, but if you want to make things a little bit more precise, but it adds a little weight. So even this method works fine for a demonstration. So this is the battery connecting lead, XT30. So here I'm connecting, you can notice these two signal wires coming from the two motors, the forward thrust motors. I'm connecting them together, and then these will go So notice I've used heat shrink properly, everything, all the connections are covered. And this makes one connector, which will go into the channel number 3. So now after please note that I have not mounted the propeller yet. This is just preliminary checking for the direction of the motor. So as you notice, this is my throttle stick. The moment I bring it forward, the motor starts spinning. So this is how I'm checking the direction of the motor, because the motors are very small, very tiny. And please note that these motors are very delicate. Please don't pull these wires, handle them with very uttermost care, because each motor is almost 6 grams in weight, which is very delicate. So, when the direction is not as per, so one direction would be clockwise, one direction should be counterclockwise. So if it is not the way it is, you can swap any two wires, or you can, I would recommend swapping the two wires is the fastest way. So now I've added the ducts in this particular gondola, and then attaching all the electronics. Also make sure that all the wires are properly attached to the airframe. There's no loose wires, because the wires can come in contact with the spinning propellers. So you can use cable ties, as you will see. You can use cable ties to hold the ESCs in place. As you can see, this region, this is the battery lead that is coming out. So over here we'll be mounting our battery, and this region is basically where you're mounting all your electronics, which is the ESC and the UBEC and your receiver. This ESC basically is going to be connected to the rudder, which is already shown previously by Professor Dhanil, because the motor was already mounted onto the fin. So these three wires are going all the way till the tail. So this is how complete connection is being done. We also need to do a pre-flight testing to actually mount the system and do the right judgment for the direction of basically pre-flight testing, to make sure that the directions are correct and according to your own comfort, basically. So please note, I'm only checking the direction of airflow. I'm not inserting my finger into the duct. This is a very beginner mistake. So, and also note that I am not, I'm giving very small inputs to the radio. So as you notice, the airship is going up when I'm wanting the airship to go up, and it's coming down the vice versa. You can notice my stick movement is very less. Also note that the meaning of a reversible ESC, that means the bidirectional motor rotation, means this stick, when it is in the center, that means the motor will be in the off state, but when it goes up, it will rotate in one direction. The moment you bring it below the center, it will immediately stop and it will immediately run in the opposite direction. So this is the we're testing the forward motor. So now this motion we're testing the rudder, and we have found out that all the connections are proper, all the directions are proper. We then head on to the flight testing. So thank you for your attention, and you can follow me on YouTube. Thank you.
I would like.
Thank you, Raman. Yeah, sorry.
Yeah, so I would just like to inform the participants. This is actually avionics part. It comes when you start doing things. So there are a lot of examples or even tutorials available on YouTube. So you should go check them out, because that is where, because every other avionics will have a slightly different way of tuning them. So that's why you need to be very, you need to look for relevant items. Like if you're looking for a certain, if you're working on a certain kind of ESC, you will look for that particular kind of tutorial. So it's case by case, basically. So that's all I wanted to add.
Okay, so yeah, so students might be a little bit overwhelmed at this presentation because it was very specific to a particular kind of system, but that's okay. I mean, there's no problem. I think you should be able to rewind this video when you see online, or watch the video recording of this again. If you want, you could also just go for the same motors which these guys have used to reduce your, but it will not be advisable if you change the shape or if you change the size of the airship. Also, if you should use it only when you use everything else the same. Okay. So, right. So now what we will do is quickly we are going to go ahead with the a small quiz. Okay, we'll go ahead with a small quiz. So I'll share the poll with you. Just wait a minute. There is one question. If we want to buy, where can we get these avionics devices for developing our own airship? So Raman or Sohan, could you answer that question? Yeah. In the meantime, I'm going to let Madhu Babu has raised the hand. See, raising hand will not help. You just type your query in the question and answer session, and then if required, we will unmute you. Otherwise, we will continue with our session. So I'm going to launch the next poll. Again, there are just 3 questions which you should be able to answer if you have listened very carefully to what we have shown you. So the poll has been launched. There were 2 polls tonight, right? Actually, this is the 3rd poll because there are going to be 4 sessions. We have 1 poll for each session. So right now we are launching day 2, session 3 poll. In the meantime, you can keep your questions coming.
Sir, there is a question, so I would like to answer it online.
Go ahead, yeah.
So the question is, can't we increase the speed of one of the 2 motors used to create forward thrust to control the respective yaw instead of using a special motor for it? Yes, you can. So here is why we don't do it. I did explain this yesterday. So when the reason is when you have the gondola, when you have these 2 forward-facing motors for forward thrust, the momentum that you have for it is quite small. Considering the size of the airship, the gondola was only about 10 centimeters wide. So each motor would have an arm of 5 centimeters. Compare that to the length of the airship, which is about 2.8 meters. So you're putting the motors at about arm length of 1.5 meter when you have a yaw motor. So there, just by giving a little bit of thrust, you are able to create a lot of yawing moment. That is not the case if you use two different speeds, which is basically called differential drive. So you cannot use differential thrust on the two forward-facing motors to control it as well as you would when you have a yaw motor. So that's the reason. I hope I have answered your question.
Okay, I'm going to stop the poll now. Unfortunately, only about 75% of the people are responding. I don't understand what is the problem in taking part in the poll, because this is not going to be used against you or to grade you or something. It's just to understand how much you are with us when we conduct these sessions. So please take another couple of minutes maximum, but do take part in the poll. At least let us cross to 80-85%. So next 2 minutes, I'm going to close the poll. Just a matter of a few clicks. I mean, nothing very difficult or very okay. Last 1 minute remaining for the poll. Okay, so now I'm going to end the poll and I'm going to share the results with you. Sohan, would you be able to?
Yes, sir.
Are you able to see the poll and the answers?
Yes, I am.
So what is or are the function of ESC? Okay, so according to me, control and regulate the speed of the motor and to provide sufficient power for the battery to the motor. I don't think they are meant for avoiding any spark in the circuit. And I don't think, what do you think? Do you also want them to transmit the speed values to the motor? Is that right?
No, sir, you are right. So it's only to control and regulate the speed.
Yeah. Okay. For proper functioning of the yaw motor, what is required? Sohan, what do you think? Which of them are correct? I don't think holes in the fins are required for proper functioning. They are required, sorry. Servo motor to let the yaw thrust is not required. Updating the firmware is a good idea. Programming the ESC is a good idea. Holes in the tail. So Sohan, what do you think?
Sir, actually, the first one is a trick option. So you don't program the firmware of the radio frequency receiver. You are supposed to program the ESC to operate the motor in both directions. So that's what Raman showed when he showed about BL heli.
Okay.
And the next one is, of course, the holes in the tail fin, because if you don't have holes, then there won't be air circulation and the propellers won't work.
All right. So the correct answer is programming the ESC to operate in both directions and holes in the tail fin for circulation. Right?
Yes.
Okay. What is the function of battery eliminator circuit? Okay, it is not an inverter that eliminates battery. That is my own imagination. Okay, neither does it ensure any overheating of the battery, nor does it eliminate any noise from the power supply. I think it's only meant for regulating and supply a constant voltage to the avionics system, right?
Yes, sir.
So the first one is correct, which has been obtained by 73% of the people, and other people have just got a little bit confused. Okay, moving on to the next one. There is a question from Ajit Chetri about concept of the motor using on the reaction wheel without propeller for yaw and direction control effective. Well, these are things which can work on a large airship. Just imagine that you are working on a very, very small airship with very small payload. You can try these things, but you are going to very soon hit a problem of excessive weight. Okay. So in principle, yes, many things are possible and innovation is always welcome, but you have to balance it with the constraints under which you are operating. Okay, so we will now move on to the next session, which will be conducted by me, and that is to do with the handling of the gas and also the flight testing. Okay, so assuming that my screen is visible and I am perfectly audible, I'll just go ahead. So handling or lifting gases, this is a very important decision that every LTA aero modeler has to make. Any gas or a mixture of gases whose density is less than air qualifies to be an LTA gas. And this table lists some of them in the decreasing order of lifting capacity. As you can see, the two top candidates are hydrogen and helium, which give you a lifting capacity of approximately 1.135 and 1.058 kg per cubic meter respectively. Hydrogen is the lightest gas, very flammable, very inexpensive. Helium is the next. There are also other gases, methane, ammonia, water vapor, acetylene, carbon monoxide, which are lighter than air. There could be other combinations also, but as you go down in this list, you notice that the lifting capacity reduces drastically. When you come to carbon monoxide, the lifting capacity is only 60 grams per cubic meter. That means if you can make an envelope of 1 cubic meter and make the envelope weigh less than 60 grams, only then you will be able to get little bit of lift. It can lift itself only if you make it below 60 grams. Okay, and that's a very, very big challenge. So the two candidates which are top in the list are hydrogen versus helium. And this is a raging debate in the LTA systems today. Working with hydrogen, the issues are that it is the lightest gas, but very, very highly inflammable. Helium, on the other hand, is second lightest gas, but it is very expensive. So when you buy this gas in retail, that means as aero modelers, you are going to buy this gas through cylinders of approximately 7 cubic meters, and you will not be buying very large quantities. So there are chances that you will be charged approximately 2,500 rupees, Indian rupees per cubic meter. This figure can vary from country to country. It will be different in the US, different in Canada, different in other countries. I don't know about the rate, but for students in India, you have to budget approximately 2,500 rupees per cubic meter. Plus, as you saw in the video, you require a regulator, you require a pipe. All those are going to cost money, but that is required even when you use hydrogen. So, as I showed you in the previous slide, the lifting capacity of hydrogen is more than that of helium. So it should be definitely preferred. Now, working with hydrogen is very scary for some people. Okay, but let us understand a little bit on the problem and what kind of issues are there. So many people say, "Oh, I'll not work with hydrogen because it catches fire." Let us look at what happens. How does it catch fire? What is required for ignition? First of all, you need the gas, hydrogen. Then you need oxygen because hydrogen itself will not ignite unless you take it to a very high temperature. There is something called as a self-ignition temperature of hydrogen, but that is very high. You are unlikely to reach that temperature. So you do require oxygen along with hydrogen. But even if you mix hydrogen and oxygen to ignite, you need a third thing, and that is a spark. Okay. Only when these three come together, you have an explosion. If you have only hydrogen, there is no danger of explosion. If you have hydrogen plus oxygen, there is no danger of explosion. Even if you introduce spark in hydrogen in the absence of oxygen, there is no danger. But when you have a spark with hydrogen and oxygen available, then there is a problem. Okay. So what will happen if there is no spark? There will be no ignition. So if you want to prevent any ignition of a hydrogen in a balloon or an envelope when you are working, you cannot remove oxygen because you are breathing it. The only thing that you can do is prevent a spark. Okay. We did a small experiment many years ago on what happens to a balloon filled with hydrogen. Is it safe when we work on that with young students? So we did a small experiment. This experiment has been widely circulated in the LTA community all over the world, and we have received a lot of appreciation for doing this small experiment. So I'm going to show you a small video. Okay, so we were doing a project.
Safety aspects of working with an envelope inflated with hydrogen. What if the hydrogen burned due to a spark? Would there be an explosion and great danger to the team members?
Sir?
The capsule-shaped test balloon previously used for an indoor airship.
Yes.
It
Doesn't matter. Don't worry about the audio. Just watch.
Sir, the video is not being shared, the video screen.
Okay, sorry. If the video is not being shared, then I'm going to share it directly. I think. Okay, so then give me a minute. Just give me 1 minute. Oh, that's the reason. Are you able to see my screen now?
Yes, sir.
Okay, so I'm going to play this video.
Before the field trial, the team tested the safety aspects of working with an envelope inflated with hydrogen. What if the hydrogen burned due to a spark? Would there be an explosion and grave danger to the team members? A capsule-shaped test balloon, previously used for an indoor airship, was used for this test. It was inflated with hydrogen and intentionally set to fire using a torch ignited with biodiesel. The balloon came down slowly, crumpled like a piece of tissue paper under an invisible bulldozer, and burnt with a colorless flame. The orange flame you see is of the plastic burning. This test gave the confidence to the trial team that it was quite safe to work with hydrogen.
Okay. So I hope you could see the video. Maybe the audio was very low in volume. Okay. So essentially what you saw is a hydrogen filled balloon which was intentionally put to fire using a flame. So what we saw is that as soon as the balloon catches fire, obviously the hydrogen gas gushes out and it burns. But after that, it is not that there is an explosion. Now, there was no explosion because of two things. One is that the gas inside this balloon is not at high pressure. As I mentioned, the pressure inside is kept slightly more than atmospheric just to maintain the shape of the envelope. So it's not a very high pressure balloon. And the moment gas comes out and catches fire, okay, the ambient air also rushes inside. And then, of course, there is fire, but there is no explosion. you can easily run away from here and save yourself. So even if you work with hydrogen and even if it catches fire, you are not going to be subjected to any bomb blast or any other danger. Yes, it will catch fire. If I can make hydrogen fireproof and also not lose its buoyancy capabilities, I would surely win a Nobel Prize in chemistry if I can do that, or if anybody can do that. We cannot change the nature of hydrogen as a combustible gas. And yes, it is highly combustible, as you saw, but it is not that there is going to be grave danger. Of course, if you are standing next to it and if you act stupid and you put a flame or a spark, then definitely there will be a danger. So if you are careful and with such small volumes that you are going to work, I don't think there is any grave reason for you to worry. Okay, so now one can talk about use of helium. Now, let us say you say, no, we don't want to work with hydrogen, we want to work with helium. Now, my question is, after you do your trial, after you fill the helium in the balloon, you do a trial, what do you do with that gas? Let's say your work is over, you want to go back home. One option is you leave the balloon in the laboratory. But then again, you will come back and work on it. After some time, you would like to deflate. And let's say there is a leak. Okay, so what do? Now you have two options. One option is just release the gas to the atmosphere. This is what most of us do with small quantities of helium. Okay, but this is expensive. As I mentioned to you, every time you blow up 2,500 rupees per meter cube, that is going to be money down the drain. And it's a large amount of money for a student or a student team. The other option is that you could try to pump it back into the gas cylinder. So you took gas from a cylinder. Cylinders are normally at a pressure of around 140 bars. That means 140 times more than atmospheric. And when the gas comes out, it is fixed in the envelope at a pressure of maybe 1.1 bar, 1.05 bar. You could pump it back to the cylinder. Okay, so you can use it again next time. The problem is that to pump helium back into a cylinder requires a helium compressor. And that helium compressor is of the order of rupees 25 lakhs. And we in our laboratory have one such compressor and the photograph is shown to you. But I don't think anyone else in the audience would have the wherewithal and the finances to buy a compressor like this for their experiments. Since we work with a large amount of helium, we do lots of experiments with students with helium. For us, it becomes viable to invest in a compressor like this, but not for people like you. So if you come to our laboratory for your experimentation, and I really welcome, all of you to come over sometime when the institute authorities permit visit of outside people. I'll be happy if teams can come and work in our lab. In fact, we are planning to conduct a follow-up workshop about which I'll talk to you later. Okay, so therefore, the drawbacks of using helium are that you cannot be very expensive, and it may become a non-starter. Okay. Plus, the gas weight is also high compared to hydrogen. We can work with hydrogen with proper care because it is easily available and highly affordable. As against 2,500 rupees per cubic meter, the cost of hydrogen commercially available can be as low as 400 rupees per cubic meter. Okay, so basically, it is about you could say 6.5 times cheaper, 6.25 times cheaper to be precise. Actually, if you go to buy helium in the market, you will find that it is going to be approximately 9 or 10 times costlier than hydrogen. So it's your choice. When we conduct the regatta in IIT Bombay, we are going to supply you helium because we are trying to get sponsorship from some companies. If we don't get a sponsorship from the companies, then we will be forced to rethink and we may have to supply hydrogen. But right now, we are very, very positive and very hopeful because still there are around 3 months remaining. We are trying to reach out to various sponsors to give us funds so that we can give helium to all the student teams who come and visit us. We don't want to charge you for the helium because it will be highly, highly unaffordable. But let's see how it goes. Okay. Coming now to flight trials. So now flight trials is something that is basically when you do it, only then you get an idea about the flight trials. What we can do today is just to show you a couple of videos. Okay. So this is the first video I want to show you. And again, I like to just check whether I will be able to, I hope I'll be able to play it now. So please confirm to me, Sohan, when I play the video. Is it visible or not visible?
Not visible, sir. You have to share the screen.
Not visible or visible?
No, sir, not visible.
Okay, wait a minute. If it is not visible, then I think probably I have to just go direct. What about now?
Yes, sir. It's visible now.
Yeah. So you can see trials of the airship about which Sohan and Raman spoke to you at length along with Vanil. They are trying to fly. So this is going to be the venue of the regatta, the Kho ground, indoor Kho stadium of IIT Bombay. And you will have to fly the airship in this particular space. We will try to get a slightly larger space also available if possible. But for the moment, you can assume that this is going to be the space. And the requirement for flying, to take part in the competition will be that there are going to be 2 pillars. You can see there is 1 pillar on the center. There are 2 pillars. You are going to require to fly a figure of 8 3 times around these 2 pillars. Okay. So the fastest airship that completes a figure of 8 flight around those 2 pillars, as you can see, Raman is attempting now, that is going to be given a prize for as the fastest airship. So it has to be a figure of 8 each time. You can notice the yaw motor on the back. So what we are going to do is we are going to allow you to practice on 25th of June. The whole day, the hall will be available from approximately 10 o'clock in the morning to 4 o'clock in the evening. You will be practicing your flights. And then on 26th, we will be conducting the competition. There are a couple of chats. Yeah, Professor Parentis has got a very good suggestion that the buoyancy of the helium depends on its purity. Okay, the helium should be pure at least 99.5%. Once the purity drops below 95%, you will find that there is hardly any lift available. Okay. So I think you have to be very careful when you buy helium. You need to ensure that the purity of the helium that you buy is perfectly correct. Okay, I'll show you one more. I'll show you one more video. Okay, which is relevant to the regatta. So I'm going to just show that to you. Give me a minute. Screen visible? Please confirm.
Yes, sir, it's visible.
Yeah. So now this video shows you the exact problem of the regatta. Problem of the regatta. You can see this is the first pillar. Okay, you are supposed to fly the airship in a figure of 8 3 times around these 2 pillars.
One
that
difference,
goes around
yeah.
the second pillar.
The one difference is it would be done at a higher altitude. So what would happen is we will be tying balloons at the two poles filled with lifting gas. So they would be at a certain height. So you have a longer pole that way.
Yeah, I mean, here we are just practicing, so we are trying to fly it so low. But as Suman mentioned, we are going to attach two balloons at the ends of these poles, so you can do this flight at a higher altitude than this. And notice Raman is not wearing any slippers or any shoes. We have been told very clearly that the students who come for the regatta have to either wear very light non-marking shoes, or just to be safe, we will not allow any footwear so that there are no marks or any damages to the floor, because this floor has been created. You can even see Shantanu with his socks. Okay. So this is what is the task expected from you. Okay. Right. So we have come to the end, and I would like to thank Naman for helping us in preparing this video. He is also there in this meeting, and he is one of our several volunteers who is going to be available even for the regatta. So thanks to Naman. And now we are opening it up for any questions or any queries. And after that, we have approximately 30 minutes for any other point that you would like to have. So I'm going to maybe just start the poll. There is one more last poll, which is there for this particular workshop. And this poll has just two questions. Okay, just two simple questions. I would like you to quickly answer them. And also we will open the floor for any questions that you may have, or any queries, any comments. There is a question by Sparsh. Can you please take it, Sohan or Raman? Okay, guys, just one more minute before the poll will be closed. So kindly start answering the questions. Around 86% people have already participated. I would request the remaining people to also participate and we can just finish the poll. There are just 2 questions, so it's not too much of time. Okay, I'm going to end the poll in the next 1 minute exactly. Okay, I'm going to end the poll now. Around 90% people have participated. And I'm going to share the results with you now. So the first question asks, which of the following is lighter than air? Although we have mentioned single choice, actually it's a mistake. We should have given multiple choice because all the 4 choices are possible. So all 4 are correct. Most people have chosen methane, but carbon monoxide, water vapor, and superheated steam also are LTA. Which of the following could result in ignition of a hydrogen-filled envelope? Hydrogen coming in contact with ambient air? No, that is not true. I have shown you a small experiment and I have clarified to you that just because you have hydrogen and air, you will not have ignition. Spark ignition inside the hydrogen-filled envelope is also not true because I mentioned to you that you need oxygen also. Inside the hydrogen-filled envelope, there is no oxygen. Therefore, if you put a spark in that, it will still not ignite. Hydrogen coming in contact with the air and a spark, yes, that is needed. So 75% people have answered that. That is the correct answer. And also the last one is lightning strike in a hydrogen-filled envelope. Yes, because if there is a lightning strike on the envelope, definitely there will be ignition because there is atmospheric oxygen available. There is spark available because of the lightning, and hydrogen is also there. Okay, so I'll stop sharing this. Okay, there is a question from Siva Vigil about, can you tell me the physical properties that can prevent the airship journey? I don't understand the question, Shiva. The main reason why you would not fly in an airship is if the atmospheric conditions do not permit. If there is a thunderstorm or if there is a prediction that there will be very, very bad weather, rapidly changing wind direction, then I would not consider flying an airship in that weather. Airships are not all-weather vehicles, we know that. So that is what comes to my mind. Okay, now what we will do is we have around 20 minutes. We will open the floor now. This is the time when you can ask now any questions regarding the regatta or regarding the workshop. And also regarding the airships, if you have general questions. Okay, because all of us are there in the meeting and we probably together can handle almost any question. Sohan has also shared the link for the spreadsheet on GitHub. You can download from there and you can use that. So I'm downloading it myself and it works. Okay. Dhanvin Mehta has a good question. Can rainfall affect the lift of an airship? Yes, it can, but very minor, unless the rain is very, very heavy. We have flown an airship in mild rain, and you must have seen the video also that we showed you. Okay, so it can. If you want, I can show you a video of one of our airships flying in mild rain. Okay. Accommodations can be given for all the team members during all 4 days. Vignesh, yes, we are trying to get accommodation in the hostels in IIT Bombay on payment basis. I think they charge something like 150 rupees per room per day, and plus there are extra charges for food. So we are trying to get accommodation for everybody. Maybe all 4 of you have to stay in one room. Maybe that will be the requirement. But we are definitely trying to arrange it, because we know that students can't afford to stay outside the campus in hotels. It will be very, very expensive. So we are trying our best. Of course, it's a matter of institute policy, and whether in the month of June the institute has rooms available. We are trying our best, and we will keep updating you. So yes, the answer is yes, Vignesh. Okay. What are the future research plans with regards to LTAs? That is Pulla Kapil's question. As the drone industry is getting a boost in India, where do you think LTA stands currently? Do you plan to make LTA commercially or any? Oh, there are many questions here. So yes, the answer is yes to everybody. Please understand that remotely controlled or autonomous airships are also a type of drones. So if the drone industry is booming, so is the airship industry going to boom in the country. And young people like you are the ones to whom we are looking forward to take up this activity. And there are many young people who are thinking of entering this particular business. Okay, so there were a couple of them in the meeting also yesterday. Today I don't know whether they are there. Okay. I'll just search. So yes, the answer is yes. There are several people who are trying to enter this particular sector.
Sir, there is one question which was asked earlier, but I asked him, so I said that this would be addressed during the discussion. So the question is, why do we consider using hydrogen, considering it is accident-prone nature?
I think we have answered the question. You cannot have a sustainable economy with helium because helium is so rare, so expensive. So if you are thinking of running airships using helium, it's going to be very difficult. It will be very difficult to sustain it. You could do it once or twice or thrice, but very difficult. Okay. Siva Vijay has clarified that physical reaction of the airship material with that environment. Yes, with exposure to the environment, to the solar radiation, etc., it does happen. It does happen that the envelope material loses its strength. It's possible that there will be increased leakage, etc. But if you use the airship carefully, it's not going to be much of a problem. Yes, there is a life for everything. In what kind of applications do LTA drones outperform fixed and rotary wing HA drones? So firstly, I'll tell you, against the fixed wing drones, endurance is the main reason, and very low operating cost compared to the fixed wing drones. Compared to rotary drones, again, the cost. The cost is going to be a huge consideration. Can a hydrogen-filled airship catch fire if temperature is high? Yes, it can catch fire if you go to the auto ignition temperature of hydrogen. And I would request Dhanvin, please check online what is the auto ignition temperature of hydrogen, and then you will know the answer whether you can reach that temperature or not. Registration fees for the workshop, is it per person or per team? Honestly, we have not taken the decision yet. Honestly, you will get to know this very soon when we update our website. My guess is it is going to be per person, because there could be a possibility that there is a team of only 2 people and we are allowing teams of maximum 4 people. So current thinking right now is that it will be per person. Okay, but we will get the correct answer when we update our website. What demonstration is planned in the pre-conference training, 22nd June? Aditya, that particular workshop is nothing to do with regatta. That workshop is to do with the usage of a software by a private company called Metacom in using their software for CFD and FEM analysis. So the pre-conference training or pre-conference workshop is nothing to do with the regatta. It is to do with software usage. Okay, please check our website www.deltas2022.in and you will get the answer there. Sheikh Mohammed, what can be the lifespan of airship that made for cargo purposes? Difficult to answer. Maybe Professor Berry Prentice, if you are there, would you like to take this question about the lifespan of the airships for cargo applications?
Oh, Dr. Pant, yes, I am here.
Yeah.
You know, it really depends a lot on what the airship is made from. Typically, the airship envelopes, if you're looking at a non-rigid airship or a blimp, those envelopes are lucky to last more than 15 years, 10 years maybe. And the difficulty with the blimp envelopes is that the leakage increases over time. So the need to actually top up more helium becomes more expensive as those envelopes get older. So that's probably what will determine the life cycle of a non-rigid airship. In the case of a rigid airship, depends again what it's made of. We're thinking that aluminum, at least half of the airship could be sheathed, get that word out, sheathed in aluminum. It might be the whole thing. The top part could easily be a fabric. We're thinking that airships like that would probably have a life of at least 25 years, and they might well be scrapped at 25 years or earlier simply because of obsolescence. I mean, we're going to see a great number of progressive improvements in this technology as time goes on. The gas cells inside the rigid airship may not have a life quite that long. And again, we don't have experience, we don't know. We're thinking at least 10 years, but it might be less than that. It all depends on the fabrication and the use and so on. I know we don't have really hard answers yet because, of course, we don't have the airships.
Correct. Right. Thank you so much, Professor Berry Prentice, for answering that question. Okay. There is a very interesting question from Yashas. Can an airship itself be used to transport helium or any other lifting gas from a seller to a buyer over a reasonably long distance? The answer is yes, it can be. Definitely it can be. But it's a good thinking. There is an anonymous attendee who wants to know, for flying outdoors, how can we counter challenges like bird hits or any bad weathers? Bird hit is not a big problem for airships because the envelope is flexible. So bird hit is not really a big problem. It will just bounce back. Bad weather, there is no way to make an airship bad weather proof except bringing it down and mooring it and putting it safely inside a hangar when the weather is bad. So if we can find a solution for an airship to fly in bad weather, then we will really improve its life and usefulness. I will take some questions first. Is there a possibility that the rule book might change? See, the rule book normally does not change because people plan their airship activity or their construction based on the rule book. So unless there is a serious problem, I don't think the rule book will change. Okay, so the answer is not likely. Okay, even if there is a change, it will be a minor change. Kamlesh wants to know what would be the cumulative cost and time span in terms of hours to make a payload carrying 10 kg airship. Kamlesh, we can't answer this question like this because these kind of numbers are very tentative. It depends on so many things. Okay, so you have to. This is difficult to answer. Okay. Aditya Argade wants to know, is there any offline workshops available? So Aditya, we are planning to conduct an offline workshop wherein we will invite students like you and participants like you to come over and build your own airships in our laboratory and maybe even test them. So yes, we are planning. The only problem is when. Okay. So I'll give you a very exact answer. Either we will do this workshop maybe one weekend before the regatta. So the regatta is going to happen on 26th of June. So this workshop could be on 18th, 19th June. Okay, that is one possibility. Okay, I think that is the only possibility. Around that time, we will be able to do that, because what can happen is you can come for this offline workshop to IIT Bombay. You can come on 18th, 19th, and 20th. Maybe make your airship, test it out, and then you can use the same thing for the regatta. You can attend the conference, and then in the end, you can use it for the regatta. That is our thinking. What is the payload to be carried by the airship during regatta? There is no payload, Vignesh. No payload is required. The regatta is only about flying the airship in figure of 8. There is no payload. Siva Vigil wants to know, is there any emergency repair station of an airship like space station? Well, I don't know about it. I don't think there is anything like that. Shraddha is concerned about the certificate and whether the poll answers attended by us will affect certificate. You leave it to us, please. The certificate business, please leave it to us. We will take care of how to give the certificates. Okay. Anirudh Sharma says, will we be provided with all the materials required to make our own airship, or we have to pay for the material also? See, as Sohan mentioned, the cost of the material for the envelope is not very high. Okay, you can easily afford it. That is the cheapest thing, I think, in this whole exercise, the cost of the material. The main cost is going to be that of the avionics and the gas. Okay, so when we conduct a workshop, we are going to charge you for the workshop, obviously, because we can't afford to, we don't have any funds available to, allow you to come here and make your airship. So we will charge you for the airship. At that time, either we will say that, okay, we have the material, you can just, it will be a part of the workshop charges, or we might say, if you want to buy the material, you can buy it. So right now we don't know, but the answer is yes, you will have to pay for everything that you use, because we don't have any funds available from any other source. It might be considered as part of the workshop fees, or what we can do is we can give you a real hands-on demo. In front of you, we will make one small airship and fly it. Okay, the thing that Raman and Sohan along with the others have done and recaptured in the video, the same thing they will repeat, maybe something else. They may think of some new shape, they may think of some new type of airship. They will make it in front of you, okay, and you will be a witness to that. Because if you have to make your own airship, it takes time. Okay, you cannot say that we will come to IIT and one day we will make an airship. It will take some time. Neeraj says that we are working on research and manufacturing of small airship. How can we reach you? You can reach me only by sending me an email. Okay, so I will just type my email. You just send me an email and then we can just discuss it. You just have to contact me via email. In fact, I will put the email in the chat window for everyone to note. Okay, so if anybody wants to associate with us in any form, this is the email that you can use. Shraddha wants to know if in future can we come and visit IIT Bombay related to have a visit airship. Yes, you can visit IIT Bombay. There are many students who come to IIT Bombay to visit here. Some of them also come to work on some projects. There is one participant who is planning to actually come. Yes, he's there in the meeting, BSN Prasad. He's planning to come very soon as part of his MTech project to build a small aerostat. So yeah, I mean, since the year 2000, when we have started working in this area, and from 2003 onwards, when the lab was set up, there have been more than 100 people who have come to the lab and made airships and gone. They have done internships, they have done projects, they have done their BTech project, MTech projects. So the works. Okay. So yes, you can definitely come. Of course, we have to work out the details. Okay. So I cannot say that, okay, everybody who applies will be given permission, because we also have our limitations. So, but if you have some interesting ideas that you want to implement, you have to just send an email, and then depending on our situation, we will take a call and permit you. Okay. So as per the schedule, we have about 3 minutes remaining before we close this workshop. Okay. So the floor is open for any other questions. I don't have a poll. How can we approach the institute for internship? So you have to look at the aerospace, you have to look at the web page of IIT Bombay. Under the academics web page, there are rules and regulations regarding internships. So have a look at that, and then you will be. Ashish Pandey wants to know what design mistakes can be avoided learning from the past airship accident from Hindenburg disaster. One is that the Hindenburg disaster has been researched a lot. There are lots of myths about the disaster. The main problem that happened during Hindenburg disaster was that the envelope was coated with aluminum oxide, which, as many of you might know, is also used in making explosives. Okay, and there is a study which says that because of a lightning strike, it caught fire on the back. So now Hindenburg happened in 1937. Okay, we are in 2002. So unfortunately, we are suffering from the stigma of Hindenburg right from the time it caught fire and made big news. So many people think that airships means they catch fire, but that is not the case. I mean, that is not the case with airships in present day times. Okay. Sohan would like to share something. He has some idea regarding the formation of regatta teams. Sohan, please go ahead, and then we'll take a few more questions.
So what I would recommend is when you're forming teams, let's say you're forming a team of 4, you would ideally want at least one person who knows some little bit about RC flying, that is avionics. So that would make your life much easier. So even if it is very little experience, just knowing how to run a motor, connecting it to a radio receiver, that would help greatly. Second person could be a pilot, because the same guy could also be the pilot, the RC guy, but not necessarily. So you can have maybe 2 people, one on working on the RC and avionics, and the other being a pilot, or maybe you can club them as one. And the others could work on making and designing the envelope of the airship, the other component. So that's one suggestion which I think would greatly help. So even in our case, when we made this airship, I was more involved in the designing of the envelope and getting it fabricated, while Raman was more involved in the RC and the avionics of the system. So it's kind of like a good way to go about it, I would suggest.
Yeah, if Raman and Suman would like, they can share their email addresses so that some of the participants could contact them for very specific suggestions. Okay, not for general suggestions, not for how to come to IIT Bombay, etc. Some technical queries if they have regarding what they saw, they will contact you. Aditya Argade says, what are the real life application of airships? Aditya, in short, I would say that application of airships are limited by your imagination. Wherever you need a vehicle which can fly for a long duration of time with heavy and oversized cargo, and which is environment friendly, which has got lower vibration levels, lower noise levels, you can think of it, except under 2 scenarios. One is, do not expect it to be all-weather vehicle, and be prepared to invest in a cost of a large hangar to store the airship, because they tend to be large and bulk in size. Okay, so that is what. While working on the airship project, will you, sir, be their guide to help us? And especially, yeah, definitely. Shraddha, I am associating with so many students like you that you don't even have an idea. So yes, definitely we help students to design LTS system. That is exactly why we created this LTS systems lab. Okay, as I mentioned to you, and I will repeat here, that more than 100 students have come to LTS lab in the last 20 years and done their BTech and Tech projects. Girish wants to talk about rigid dirigibles. What is the smallest size for which a dirigible makes more sense? As Professor Barry Prentice also mentioned in his talk, rigid dirigibles are structurally very effective if they are large in size. So unless you have them approximately 100-125 meters in length, they do not become structurally worthwhile because of the heavy self-weight. So if you want to make a small rigid dirigible, you either have to invest too much in very, very high technology to make it extremely lightweight, or else you will be ending up with a lot of dead weight and less payload capacity. So the larger you make a dirigible or an airship, the better it is, even for a non-rigid type. As he showed a very beautiful picture where there is one airship that can carry 2 tons of payload, and something which is only 4 times longer can carry 60 tons of payload. What will be the salary of an LTA systems engineer, and in which aspects can we settle in this sector? Sheikh Mohammed Arshad, there is very limited openings available in LTA sector. So as far as career options are concerned, you may not be able to find a job as an LTA engineer very easily because it's a niche job. It's a very, very specialist application. Harshit Khatri wants to know, are there any ongoing projects on conventional UAVs in IIT Bombay? Harshit, IIT Bombay is a huge institute, and it is, as you know, the top ranking institute in the country for research. Definitely, there are several projects going on conventional UAVs in IIT Bombay. Okay, many are going on. I can't even hazard a guess how many. There are so many of them. Okay, so we have crossed our time by about 5 minutes. This is a time when we can now quickly take some feedback. Okay, Tushar Sharma wants to know, can airship be used for air travel? Yes, they can be used with the limitations that I already mentioned. Dispatch reliability of airships is poor because of their weather dependence. Okay, and they also have limited maximum speed. About 150 kilometers per hour maximum is the speed of a conventional airship. So within these limitations, yes, they can be used, but I would not recommend them to be used for transporting passengers to start with. Most suitable for transporting cargo or oversized equipment. All right, so we might be able to take 1 or 2 feedbacks. So if somebody wants to give any feedback, I would like you to just raise your hand if you want to speak something about the workshop. Sparsh has got a feedback. He says he visited LTA during students for testing the airship during TechFest, and when I was in 8th standard 4 years ago, and he's very happy to connect with us. Okay, thank you, Sparsh. So the floor is open. If somebody wants to give a verbal feedback, we will unmute you, but you need to raise your hand. If you raise your hand, we can probably unmute you and you can speak very briefly about your experience with this workshop. We cannot go on for a very long time because we have already crossed the time limit by 5 minutes. Vignesh has raised the hand. So Vignesh, you're allowed to talk now. Go ahead, Vignesh.
Hey, thanks, team, for the detailed workshop that you had given, for the 3 days. Being in industry, I'm working as a materials project manager in applied materials. But being a LTA enthusiast, it's great to see too many details that's being shared, because once you come to a corporate, right, they are very much stringent and constrained about their information, what's shared to the public. But here in the great platform, you get to see many researchers sharing their ideas, and great to learn. It's very glad that the platform like this exists, and hope this is going to get continued for years together. Thank you.
Thank you, Vignesh. So that is the difference between an industry and an academician. So we in academia are very open, and we would like most people to, ask questions and get their doubts clarified. We don't have any secrets which are there mostly with the that you see in the corporates, and we understand they have a different way of looking at things compared to us. We are very open and we want to share our knowledge and invite people to come and work with us. Is there workshop only for LTA or other fields also? Aditya wants to know. Aditya, workshops keep happening for various topics. We are conducting workshops even on drones, like Raman is an expert in palm trop. Raman and so on, they have conducted with me workshops on palm trop drones. we go to colleges with kits and we make the students, participants, assemble a small palm top drone, learn how to fly it, and then we conduct a competition. So we have a one-day workshop like that. In case you want us to do that workshop in your institute, just write a mail to us. Okay. So we do a lot of workshops. I do a lot of workshops on aero modeling also, on how does a plane fly. Okay, Shraddha has some positive comments. Anybody else would like to? Okay, Divyanshu Aman says that it is my dream to make LTA with some innovations. I didn't have any to achieve my dream, and these 3-day webinars gave us support. Very good. Kamlesh has raised the hand. Kamlesh, I think we will just allow you to talk. I don't know, 1 minute. Kamlesh, do you want to speak? Just raise your hand once again if you want to speak. Okay. Yes, Kamlesh, please go ahead. You can talk now. Yeah.
Hello.
Yes.
Yeah. So this is a great workshop I had. I'm going through a tough health issues, but seriously, going through this workshop and the size of the airship, and the same I have communicated with my students who are following or going through the SIE aero modeling challenge workshop. They also very keen interested, and I'm so thankful to the IITians organizers who have really helped them to attend this workshop. Apart from it, sir, the whatever the messages we put, questions we put, it was promptly answered and justified as well. Um, that's so great to see that we were so punctual about the timing to starting and of ending, and the given and take had happened between the speaker and the receiver end of a participants was really helpful. Thanks a lot for organizing this event, sir. Thank you.
Thank you so
And
much.
looking
Thank you
forward
so much.
and thank you and looking forward for you. At least 3 groups from our side would be contributing toward the conference or the workshop, sir. Thank you,
Wonderful,
sir.
wonderful.
Thank you.
I mean,
Thank you, sir.
if we can motivate most of you people to come for the regatta, whether or not you are able to make the airship doesn't matter. But if you can develop interest and passion coming for the regatta, I think our effort is worthwhile. Okay, so we would like to, right now you're all names in front of us. Okay, we have Sparsh Ranaware from Nagpur, we have Dhanvin Mehta, we have Girish. But we would like to meet you guys, we would like to see you, and we would like you to be in front of us and share our passion. Okay, there is Neeraj who wants to talk. So Neeraj, please go ahead. I'm trying to unmute you. Yeah, go ahead. Yeah, you can speak.
Hi,
now.
sir. The
Yeah.
great workshop was great, and all concepts about avionics, about design and fabrication was made clear, as we are planning to design and manufacture a small airship or aerostat. We 1 week or 2 weeks ago, we just read your research paper with Rishabh Sehgal sir, and we were confused about what we have to design, on which software we have to analyze it, which avionics we have to put in that airship or airostat, what weight or what structure we should consider. So that all concepts were made clear in this workshop. So I am very grateful to attend this workshop.
Okay, so there is a message from Dr. Manish Tripathi. I think I'll request him to speak. You can unmute and speak, Manish.
I would request all the participants who are interested in taking part in the regatta that they fill in the pre-registration form, which is available on our Delta's website. So that will actually give us a brief idea of what we are going to expect as a football. And based on that, we can also carry out further planning related to the regatta. So it is highly requested that all the interested participants do fill in their pre-registration forms on the website.
Yeah, let me add that there are no charges for that.
Yes.
The pre-registration form is only for our planning. So if you fill the form, we come to know at least how many people are interested. So should we book 100 rooms or 50 rooms or 10 rooms? To plan that, we need to know how many are really interested. So it will give us an idea. Okay. So thank you, Akanksha, for your positive comments. And I'm happy to note that some people are trying to do a cross communication, like Girish and Sparsh. They are both from Nagpur and they are connecting with each other. There was a question about whether we can have a team from different colleges. Yes, you can. You don't have to be in the same team, same college. Okay. So don't worry that Divyanshu, if you are asking for college name, we are expecting people from the same college, but the team leader can put the college name. It's not very important actually. We are not really worried too much about which college you're coming from. We just want to know how many people are coming. Ajit Chetri says, I would like to say that the amount of knowledge that was packed was appreciable and free of cost. See, we made this workshop free of cost because we have been funded by the Shastri Indo-Canadian Institute. So we did not want to really worry about charging you people. And why should we charge? If you are interested, if you are interested in the workshop. Okay, Abdul Rahman has a small complaint that if somebody asks you about certificate, then you respond strictly. Yes, Abdul, please understand that if people are interested in certificate only, then they are in the wrong place. Okay, this workshop is not meant for people who just want to simply get a certificate for it. Okay, we are not here to worry about that. We will give certificates. See, we have a list of all the people who registered, and we will have a look at the attendees and we will take a decision. So you don't worry about it. Okay, I think that should be the least of your questions and worries right now. Otherwise, we get the impression that all you want is a certificate. You're not interested in what we do, what we say. Harshit Khatri would like to share his views. I'm going to stop in 1 minute. Harshit, this is the chance for you to speak. So I'm unmuting you, Harshit.
Thank you, sir. So my area of interest was UAV, and I was not at all interested in LTS systems initially. But when I attended your seminar at SVIT Vasad, I got to know brief about it, and that's why I attended this. So now I have a clear idea that how can I implement the LTS systems in my ongoing project. So
wonderful.
Welcome. Very helpful for me.
Welcome to the enthusiastic world of LTS systems. Okay, so on that note, I think we can close the workshop. Aditya Argade. Okay, Aditya Argade, we will stop with you. So last question. Last person to speak, Aditya Argade. Please unmute and speak.
Yes, sir. Sir, sorry for late. Sir, thanks for organizing such a good section. Actually, I cleared my all concept related to LTA, and I am looking forward to work on a LTA project in future. So I would like to meet you in future.
Wonderful, Aditya. I'll be happy to meet. We can work out a plan based on mutual convenience. Send an email at the address which I have mentioned.
Yes, sir. Yes, sir. Okay, sir.
Okay.
Thank you, sir.
Thank you. Thanks a lot. I think on that note, I think we would like to stop this, end this workshop. Srinidhi Keledar has some positive comments. Thank you so much, Srinidhi. And I think it's time for us to say goodbye. We have spent 3 evenings together in India, and I'm sure there are many people from other countries also who are also part of this workshop. And we are thankful to you for being with us for the entire workshop. And even though the time differences between India and your country could be inconvenient for you, but still you have taken the trouble of being with us. So we are very thankful to you, and we would like to we would like to thank you for being with us. We are going to update our website. Right now, we have a website of our lab, but we're going to update the website very soon. Okay. So you have my email address. Please send an email in case you want to discuss anything. Before I close, I would request Professor Barry Prentice to give us some closing remarks on his experience with us on this workshop. Professor Prentice, over to you, and then we will stop the workshop.
Well, thank you very much. It's a great honor to have the last words in this. I'm really pleased with the workshop. I think the ability to actually physically show how the balloon is, or the petals are formed, how they're sealed together, how you go through all the caution and the electronics. I mean, this is a fabulous workshop. I hope this record is saved for a long time, because I know that it has a value that could be used anywhere in the world. And of course, I also really appreciate just the efforts that you're making to educate a lot more people to airships. You know, the comment came up about the jobs in this field. And it's true that as of today, you'd be hard pressed to find employment as an airship engineer, perhaps. But this is not the future. We must move to a future with lower fuel consumption, lower carbon emissions. And in terms of air transport and air cargo, the airship is really the only solution that we hold for the future. So I'm very optimistic that we're going to see a long-term future in airships, commercial airships, and I'm also very convinced that it will be hydrogen filled as well as hydrogen powered. And this is a great opportunity for students who want to get involved in the future to pick up this and learn these basic principles today. And thank you so much to your entire organization. I know this is a lot of work and a lot of time that you've spent and prepared this, and you've done a wonderful job. And again, as an observer, thank you so much for allowing me to be involved in seeing part of this. And I'm sure I speak for many people who are watching today. So thank you again very much.
Actually, the real people behind this are Sohan and Raman, the guys who not only made the airship that you saw flew it, but also they made the presentation. So especially Dr. Sohan Suvarna, we need to acknowledge his total participation in this, and also that of Professor Dhwanil Shukla. So friends, it's time to say goodbye, and I'm going to now stop the meeting. Thank you all, and let us be in touch. Okay.